So I'll be doing revision of calculus for social science, just a reminder of what was done in the semester. So let's start off with limits. So if I have the limit as x tends to 3, for the number 2 is 2. The limit of a constant is a constant. So if I have the limit as x tends to -1, and say this is 3, then the number is just 3. However, if I have a function with a variable, so I have the limit as x tends to 1, 3x plus 1, I replace x to be 1, so it'd be 3 times 1 plus 1. 3 times 1 is 3, plus 1 gives me 4. Now, we can also have, for example, the limit as x tends to 2, and say we have x squared minus 4 over x minus 2. If I replace x to be 2, I'll have 2 squared minus 4 over 2 minus 2. 2 squared is 4, so 4 minus 4, that's 0 over 0. Now, in this form, we have to do more work, which is factorizing. So x squared minus 4 is difference of 2 squares, so I can rewrite x squared minus 2 squared, which is x minus 2 and x plus 2. So that means I can replace this numerator. So I have the limit as x tends to 2, and I have x minus 2, and then x plus 2 over x minus 2. I did this so we cancel here, so I have the limit as x tends to 2 for x plus 2, and then replace x to be 2, so we have 2 plus 2, and that is going to give me 4. So my answer is 4. Limit as x tends to 3, x squared minus 5x plus 6 over x minus 3. Now, for this scenario, we always substitute x equals 3. Whatever it tends to, we have to substitute it to see what's happening. So we have 3 squared minus 5 times 3 plus 6 over 3 minus 3. 3 squared is 9, 5 3 is 15, plus 6 over 3 minus 3, that's 0. 9 minus 15, that's minus 6, plus 6, that gives me 0. Once you have this, we have to do more work, which is factorizing, in this case, the numerator. So I'm going to factorize the numerator. So I have x squared minus 5x plus 6. So I need two numbers that multiply to give me positive 6. When I add, I will get negative 5. So what are these two numbers? If you're having problems factorizing, just think of what gives you 6. But given that there's a negative sign here, it assists us in knowing what to do. So I will have negative 2 times negative 3. And I will also have, well, you wouldn't use negative 6 and negative 1, because even though it multiplied to give us positive 6, when we add, it doesn't give us negative 5. And the next combination, we cannot use negative 6 and positive 1, because even though it add to give us minus, and the next combination, we cannot use negative 6 and positive 1, because even though it add to give us minus 5, when we multiply it, it gives us negative 6. So the best combination is -2 and -3 because when we multiply, we get +6, and when we add, we will get -5. So the factors are -2 and -3. Now, when we have our factors, we are going to replace the center with the factors. So we have x squared minus 2x minus 3x plus 6. Now group, what can I factor out of the first? The only thing that's common is x. So I'm left with x minus 2. What's common here? I can factor out -3 and I'm left with x minus 2. So that means I have x minus 3 and we have x minus 2. So the numerator I will be replacing. So I have the limit as x tends to 3. And for my numerator, I have x minus 3. And we have x minus 2. And the denominator, we have x minus 3. So these cancel. So I'm left with the limit as x tends to 3, x minus 2, and replace x to be 3, so it's 3 minus 2, so that gives me 1. So my answer for this is 1. So if I have the limit as x tends to infinity, 3x squared plus 9 over 5x squared plus 4x. Once it tends to infinity, what's going to happen is that we have to divide by the largest variable. And dividing by the largest variable means that we have to identify which is the largest variable, because substituting infinity, we're just going to have infinity over infinity. Remember, infinity represents a very large number. So dividing each by x squared, because that's a larger variable in this case. The larger variable is x squared. So I have the limit as x tends to infinity. We have 3x squared divided by x squared. 9 divided by x squared. So every single term, we are going to divide it by x squared. So we have 5x squared divided by x squared plus 4x divided by x squared. And let's simplify. Now, this will give us 3 because the x squared cancels. So we have the limit as x tends to infinity. This is 3. This is 9 over x squared because nothing to be canceled. This would cancel, so I'll have 5. And then x, one of the x's cancel. So I'm left with plus 4 over x. So for this, the limit of a number is a number, so that's 3. Number over a variable, once simplified, that's 0. And the limit of a number is 5. And for 4 over x, that's 0. So my answer is 3 over 5. Let's look at another one. Suppose we have several variables. So we have the limit as x tends to infinity, and we have 3 plus x to the 4th over x cubed plus 2. Now, let's put 2x. So we have x to the 4th, we have x cubed, and we have x. Always identify the largest variable. In this case, it's x to the 4th. So I am going to divide each term by x to the 4th. So I'll have 3 over x to the 4th plus x to the 4th divided by x to the 4th. I will also have x cubed divided by x to the fourth plus 2x divided by x to the fourth. Now, for this one, there's no simplification. It's just going to be the same. So this is going to still be 3 over x to the fourth. X to the fourth into itself goes one time. So we have plus 1. X cubed, cancel it out. So we have 1 over x being remaining. Well, for here, cancel out one of the x's. So I have 2 over x cubed. Now, after canceling, this is where we say the limit of this as x tends to infinity, that's 0. Limit of 1 is 1. Well, this would be 0, and this would be 0. So that means 1 over 0 would give me, so your calculator would give you math error. So it means our answer is infinity. A number over 0 is infinity. If we had 0 over 1, then we would have said our answer is 0. So 0 divided by any number is 0. Let's look at continuity. Now, suppose we have the given function, which is a piecewise function. So given the following piecewise function, it's saying x is less than 2, we have x minus 3. For x greater than or equal to 2 but less than 5, we have x squared minus 3. And we are going to find the following. So if I want to find f of 1, because of this symbol, it tells me 1 falls in this range. So that means I replace x to be 1, so I have 1 minus 3, so that will give me negative 2, because I use this function. If I have f of minus 2, negative 2 also falls in this range, so I'll use this function. So it will be minus 2 minus 3, so that is negative 5. If I want, say for example, f of, say, 3, then 3 would lie in this range. So what that means is that I would have 3 squared minus 3, which is 9 minus 3 to give me 6. If I want to find the limit as x tends to 2 coming from the left for the function f of x, and I also want to find the limit as x tends to 2 coming from the right. Now, for the same function, f of x. If you realize, the minus sign behind the number tells us it's left, and the plus tells us it's right. A great way to do this, I like to draw a number line, and I will have 2 and 5. Those are the numbers that were given here. And for x less than 2, I'll have it right here. So the function is x minus 3. And then for x greater than or equal to 2 but less than 5, we'll have the function x squared minus 3. I like to say to students, identify the number that we're interested in, which is 2, and the function that's directly on the left, that's what satisfies this. So this would be the limit as x tends to 2 coming from the left. I will have x minus 3 and then replace x to be 2, so it's 2 minus 3, so that gives me negative 1. So in the same case, this is a function that's directly on the right of 2, so I will use the x squared minus 3. So I'll have the limit as x tends to 2 coming from the right, and it's x squared minus 3. So I'll have 2 squared minus 3. So that's 4 minus 3. So that gives me 1. Now, once the left and the right is not equal, then it means the limit as x tends to 2 for the function does not exist. So this does not exist. And it does not exist due to the fact that these are not the same. So once they're not the same, it does not exist. Another key information is the test for continuity. For a function to be continuous, f of 2 must be defined. In f of 2, I would use this because it says equal. So I replace 2 into this function. 2 squared minus 3. So that's 4 minus 3. So that gives me 1. The next condition is that the limit must exist. But we just found out that the limit as x tends to 2 for the function, I am going to write DNE, which means does not exist. However, do not write that in your exam. Write out the word does not exist. So since this does not exist and the value for all this is 1, f of 2 is 1, then what this means, it is not continuous. So these are not continuous due to the fact that the limit does not exist and f of 2 is 1. For a function to be continuous, these must be the same. Let's look at one that is continuous. Now we are going to test if the following piecewise function is continuous. And we are going to test it at x equal 1. Is this function continuous at x equal 1? So first, I have to go ahead and find f of 1. Since this is equal to 1, then it means I replace 1 here. So 1 minus 6, that gives me negative 5. Next, I have to find the limit as x tends to 1 coming from the left for the function. Now, you can always draw the number line, have your 1 and the 6. And x lesser than or equal to 1 will be on this side. So this side will be x lesser than or equal to 1. So I'll have x minus 6. While for here, I will have x is less than 6 but greater than 1. And the function is 2x minus 7. Doing this assists us in knowing which function is on the left and which function is on the right. So here, this is on the left of 1. So it means the function I'll use is x minus 6. So the limit as x tends to 1 coming from the left, it would be x minus 6. And I replace x to be 1, so I have 1 minus 6 to give me negative 5. The limit as x tends to 1 coming from the right for the function f of x, I will have the limit as x tends to 1 coming from the right, it would be 2x minus 7. So replace x to be 1, so I have 2 times 1 minus 7. So this is 2 times 1 is 2 minus 7, that gives me negative 5. Coming from the left is the same as the limit as x tends to 1 coming from the right. So since they're equal, because I've just found them to be negative 5, then it means the limit exists. So the limit as x tends to 1 for the function f of x is negative 5. So the final
condition is that since f of 1, which is -5, is equal to condition 2, which is a limit as x tends to 1, and this is a little statement that you would make. So since they're equal, that's 1, then we say it is continuous at x equal 1. Since f of 1 is -5 and the limit exists and it's also -5, so since both of them are the same, then we say it is continuous. And that's it. Don't forget to like and subscribe to my channel. Have a great day.